Hello, my friends. It's Roger, Mud Fossil University, looking back on my life today, and I really was like somebody working on alien technology. I'm telling you, I came into this business of electronics when it just started. Nobody knew about electronics, really. They were in the world of mechanical devices, creating adding machines and all of the different things that they now use the electronics for. Now I went through. Well, let me just show you one thing. Hold on, where is it? This my father was. That's my father, and that's a 1936 Ford that was made in 1936, and it's stainless steel. They tried. They made six of them, and they're just too hard to work. That kind of steel, it's too strong. Anyway, my father was in charge of Wallingford Steel. He was a general manager, and this was their stainless steel, super metal, strip out, everything. And I learned a lot about this. He was metallurgy, and I worked on his car actually. I put the floorboards in there, and they were boards. They were made out of wood. Anyway, this goes back a ways for me, and then I was in the army. I was in nuclear missiles, Nike Hercules, and I got out and I was in electronics, and then I had my own businesses, and I had, I was very successful. We had a lot of different things going on, but let's talk about the material aspect of what I almost feel like, seriously, I feel like I was working with alien technology. And literally I was, because nobody knew anything about this stuff. These were circuits that had all kind of little things, well, stuff like this. Things like this sticking out of them. And they said, well, how's that work? Well, we had to come up and understand what is inside it. What does it do? Why does it do what it do? Why does one of them create a voltage and one of them store capacity and one of them turn a switch and one of them stop the stuff from going both different directions? And what is a choke coil? And I mean, 100 different zillion things that these did that we had to understand, and I did. I understood it very well, and that has led me to understand exactly what the structure is internally in molecules, atoms. And they're constructed of electrons, what we consider an electron. It's really nothing more than a little tiny ball. Every one of these is just like that. Each one of these, you see black and red, black and red, black and red, they're electrons. I'm going to call that an electron. It's one of these. These are the things that circle a nucleus. Well, what is the nucleus? The nucleus is just a ball of these. That's all it is. And there is certain frequencies, which is a frequency just happens to be a vibration. Now, extreme frequencies have a different attachment value than lower frequencies. They're just sort of holding lightly, and they're really tight frequencies. They're locking things together. Now, at certain resonance values, which means that, and they're very specific, and there's huge gaps between these resonance frequencies. So let's say one of them is 200, one of them is 1,000. There's 800 different little bitty particles and things that can happen in between there. It's very, very, each proton that they call right now a proton, in my world is 1,836 of these little bitty bits together. And at 1836, it's a proton. And that means it is stable. You make 1837, 1838, 1850, 1860, then it starts to fall apart. And that's why these weights and measures that they had set aside years and years and years ago are now weighing less. The particles literally fall apart. What it has to do is leave from the nucleus. Just leaving from here is nothing more than electricity, static. Those things can move around. Heat. That's what's moving here. Once you change weights, you've left the nucleus. And that happens over long times. It's called transitioning. All right, let's get a little deeper. We're going to get into some of the light research and pictures and so forth I did with Rodney Warren a few years back, and they are stunning. Rod came up with a Venturi accelerator that is 2 round metal drums, and the light is forced to crush itself and accelerate. That is the nature of a Venturi. The restriction forces that. And all of the display is seen in absolute fabulousness. Now, this is what my theory is that electron flood theory is this. And what it tells us is that every particle in a proton is nothing more than an electron. And an electron is nothing more than a ball magnet that has a positive and a negative side. This is 1,836 balls. It becomes stable, and if you add extra balls or take them away, it's what's called isotopes. All right, this is a proton. Now, it consists of 1,836 of this size, which is a very small number, 0.005485 atomic mass units. And these electrons are dipoles. They have a positive and a negative side. They are called 1 electron volt, and I can explain that. Millikan's oil drop experiment shows it's pretty obvious that they are pulled to the earth with a certain value of electrical current, and they are calling that 1 electron volt. I will get deeper into that if you would like. It's very simple. Well, I might as well do it now. What happened was Millikan was making drops of oil, tiny, tiny, tiny little drops of oil, and letting them fall to earth, and seeing how quickly they fell, basically, how hard they hit the earth. And he was shooting electrons in and attaching the electrons to these oil balls. And he realized that every ball fell at different rates. He couldn't make just 1 electron attached. So, but every time he divided out the differences, it came out to a whole number, and that whole number ended up being 1.6 something to 10 to the minus 23. It's tiny, 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 tiny little thing. And instead of using all that nonsense, he just said, let's call that 1 electron volt. So what does it mean to us? It means that one of these electrons is pulled to Earth by something like a battery that had 1 volt of pull. That's all it is, because the Earth is a puller. The Earth sucks every electron it can take, although it's taking them less and less aggressively because it's filling up. Our entire realm has more electrons than it necessarily wants. And we're seeing discharges into space, sprites, Steves, these auroral blasts that you see going out to space. That's not the way it's supposed to work. They're supposed to come this way. Now, whoops. Now, electron flooding is that particle. Photons are nothing more than 2 of these together. That's a photon. Right? Like 2 little bar magnets held together. And protons, and I can show you this in light experiments that Rodney Warren and I did years ago, using simple little laser, just like that. Now, protons are 1836 of those, but that's an average. They're not 1836 100% of the time. They averaged it out to 1836 because every one of these adds. It's not one gigantic proton that weighs 1836 times an electron. It's 1836 electrons in a ball makes a proton, and at that frequency, they will stay together. They do not want to leave each other. They would call that the strong nuclear force. You throw a few extra ones in there and they start hanging off on the edge like that. That's the weak nuclear force. Those are isotopes. Those are additional extra particles that are within the core nucleus. Now, neutrons are just a couple of extra electrons attached to a proton. Just think about it that way. Isotopes are just more and more. There's different chunks. S orbital atoms are just anti-gravity because they don't have enough a negativeness to it to come to the Earth, which is a positive polar. So instead of them coming to the Earth, having enough negativity, they're pushed away from the Earth. Hydrogen more aggressively than helium. But they only have the orbitals in the S orbital. Now, above that, they become attractive to the Earth. Now, Dave Hudson, and you can look him up, David Hudson, he did research on sludge that was on his farm property, and he found out that it was loaded with heavy metals. And he did some extremely deep research, deeper than anyone in the entire universe that I know of, by himself. And I salute this guy. He will be known as a hero forever. He did long burn times vaporizing different materials and then seeing what they produced. This gets very deep, but it shows that at certain rates they just spit out an extra electron, which they said, oh no, let's just go this way. They said 45 seconds, all these particles are gone that are extra particles that are floating around. Well, maybe that's true, but there's particles in here that can leave. If you heat it hot enough, over and over and over, they eventually will throw them out of the core. They never expected this, but he absolutely, positively, undeniably, unimpeachably, unequivocally, for certain, and on top of that, without doubt, showed that these particles can leave the core if you additionally heat them over and over and over, and it ends up being called monoatomic gold. And guess what? You get the core in a condition where it does not care anymore about keeping electrons away. They all go away. They just go away, and it's now become like hydrogen in the case where it just doesn't care about electrons out here. So one is fine, who cares? It ended up being anti-gravity and actually losing weight, and it was still gold. You have to look at this. I did a couple of videos on him, or at least one. I'll try to link it in here somehow. So we're into isotopes. These are just floating around. These little bits of things float around. That's what isotopes are. S orbitals, anti-gravity, and electrons in my world know what to do when they get amongst them other friends in quorums. A quorum means that if you're going out to play baseball, well, you don't come out with your lab coat on and your instruments to do chemistry. You go out with a baseball bat. You know what you do because you're in among people that are doing those things. It's a quorum. The same thing when you go into a certain classroom. You don't go in there with a basketball if you're going to be learning about chemistry. It's just the way it works. So you have to go in there understanding what your place is. And they understand extremely well. Better than we do.